Welcome to the DevOps Online Summit. My name is Tracy Reagan, and I am the CICD Track Chair. Today we have another amazing speaker, Steve Taylor, who will be sharing some of his insights around microservices, how to track microservices, and how that impacts the CICD pipeline. Welcome, Steve.
Hi there. Thanks for having me.
Steve has quite a interesting background. He has been in the business of DevOps even before I believe we were calling it DevOps. He is a visionary and industry leader in the area of microservices, Istio, Kubernetes, and overall DevOps process improvement, particularly related to microservices and how they're released and configured. Steve is the mastermind behind a product called OpenMakeMeister, and he is the community director for the architecture around Ortelius and one of the main contributors to the open source project. He's also on the Tecton project and works on the CD Foundation's interoperability and EventSig. So he is a busy person. So thank you for taking the time out today, Steve, to talk to us.
No problem.
So really, what drove you for the topic here at hand, tracking microservices in your CD pipeline? Can you kind of explain the general problem set that you're addressing here?
Well, what's happening is the microservices are changing the landscape of the CI/CD pipeline. And the main reason is because of the quantity of the microservices. When we look at breaking a monolithic application into the smaller microservice pieces, we go from having, our one big, ear file that we're deploying out to WebSphere, for example, to creating hundreds of microservices to do the same functionality. And that's going to cause the whole pipeline process to need a different approach to manage that quantity of microservices that we're going to be tracking.
So in general, what are you seeing from customers? How many microservices are they, when does a problem start?
Yeah, it's been interesting. In the last, I would say, 6 to 8 months, about 6 to 8 months ago, we were talking to people, and most teams that were venturing into the microservices world were around 20. 20 was like the max that we would see. But recently, when we've been talking to people, it's jumped up to 100 or 200 microservices that they're trying to manage. So it's been an exponential growth when you journey down this path of microservices. It does have a lot of benefits, but also it has some difficulties that we'll point out today.
And then in terms of, they're running that many microservices, and how many clusters do you see people? Is it 3 clusters like traditional dev, test, and prod in the pipeline?
That's the interesting part. We're still stuck in that world with microservices. People are still approaching microservice development like they would a monolith. Giving my server, let me put my version of my monolith on this server, and that is, I get to control it, and that is what we're going to be doing our testing on. And then when we're done with that, we'll move it to another server. That's still happening, what we see with the microservices, where people are wanting clusters. I had a call this morning where developers were wanting their own cluster for testing a change just to their microservice. So right now we're seeing cluster sprawl, and I think people will soon realize that they're back into the same world that they were in the past with server sprawl, and it's going to get very expensive when everybody wants their own cluster. So I think in the next couple years, we'll see that kind of go back to a centralized world where multiple developers and changes are being shared within a single cluster. and possibly, they may even just go to dev test prod as the big clusters, a development cluster, a test cluster, a production cluster. But I foresee down the road that we'll just have one cluster, which will be production, and we'll be doing development changes in production. And what's going to really cause that to shift is the people embracing and understanding how to leverage service mesh like Istio, and being able to route developer changes to a developer where they're picking up just their changes plus what's in production. It does make things easier, but also there's some pitfalls that we're not going to get into down on this conversation.
Well, let's just talk about what really is different between a traditional application, monolithic application, and an application that's built around a microservice, service-oriented architecture. What are the real core differences in how we manage them, how we view them? Is there BOM reports? Are there difference reports? How does that change?
So in our traditional world, we'll just take Java since it's a easy example. So when we would create our app, our monolith in Java, we would go through a process of creating our classes from our source code. And then we would go ahead and go through a compile step to translate the Java code into bytecode. And then we would go and do what we would call the link process. We'd jar up the classes. And that was basically we're packaging together all the different classes and objects into that monolithic jar file. Now, obviously, we would then take that and roll that up into an EAR file with all the web resources and pieces like that. But at the end of the day, we had a file that was a consolidation of all the different pieces and the specific versions, because we had the build engine controlling which versions of which source code, which libraries you wanted to include. So all that was kind of resolved at build time. We ended up having an EAR file that we could actually check in to, like an Artifactory or a Nexus, those types of repositories. We could put a version tag on it, and we can keep track of that, and we can move it around. Now on the microservices side, when we look at a microservice architecture, if you have, let's say, 100 tables that your monolith was referencing through the different Java classes, in the microservices world, you typically will end up with 100 microservices, if not more. That would probably be the minimum. You want to look at your CRUD for each table, your create, retrieve, update, delete, and those would be the 4 transactions that would be a microservice would be doing, for example, around a user profile object or table. We'd have those 4 transactions packaged into a microservice. Now, for scalability, we actually may break that out into 2 microservices. One where we're going to have the retrieval type of microservice against the user profile, and then we have the other one that's going to do the create, update, delete. The reason for that is because the retrievals will happen more frequently, and that will allow us to scale that microservice independent of the other create, update, delete microservices. So, if you take 100 tables and we have 2 microservices per each, we have 200 microservices that we're now managing. The big thing that's happening, even though we have this huge number of microservices, the amount of code in each one of those microservices is going to drop drastically. Instead of being in the monolith where you're going to see like a 10,000 or 30,000 line piece of source code, the microservices are going to be written in languages like Python, Rust, Golang, and their source code footprint is going to be much smaller, into the 50 to 100 lines of code instead of tens of thousands of lines of code.
So what you're saying is that you have you have a build process that no longer is doing a link, and you have a lot of small libraries that you're managing outside the traditional compile and link process.
Yeah, what happens is in the microservices world, we're deferring the link from compile and build time over to the runtime. So we're actually doing dynamic linking on a per transaction layer at the runtime level. So that's where we have to figure out that we have the right versions of microservices matching up.
So you're working on the Ortelius project. And the Ortelius project is a configuration management solution for to solve these kinds of problems. Talk to us about what happens to the application. Do we have an application anymore in a microservice architecture? And how that impacts the pipeline. Do we push these microservices individually, which I've had other speakers said yes, the poly repo and the individual workflows is what they push for. What are your thoughts on that? So how do we configure, where's the application, and how does that impact the workflow?
Yeah, so what ends up happening is in our monolith, we ended up with an ear file in our example that we can actually, it was simple, there's one of them or a couple of them that we would need to manage, move around through the pipeline. And that was basically our application. You know, we can put our arms around it, and we can version that. We can have a version number for that ear file. Now in the microservices world, what's happening is you're going to have a different version of every microservice. So if we go back to our example where we have 200 microservices, and then we have 3 stages of our pipeline, dev, test, and prod, we have potential to have over 600 versions of our microservices. Now we need to pull those together because a microservice by itself doesn't really do anything. It has a specific task that it does, but it doesn't, it can't work independently to, you know, provide all the data to a web page, for example. You have to tie the microservices together into a version of your application. So that's where we talk about the logical view of an application. From a logical standpoint, what is the list of microservices and the specific versions that I need to represent, you know, version 10 of my application. So that's where the configuration management comes into play, and Ortelius handles that really well because it understands how to track these complex many-to-many relationships and build up the logical view that we've lost from the monolith when we moved the microservices.
Interesting to think about how those moving parts kind of impact application versions. Do you add then the cluster that it's running in? Because can't you have different versions of microservices running in different clusters that make up different versions of the application? So in other words, in our old world, we would have compiled that and we would have said this combination of libraries makes up this version. But now, since we're linking at runtime, that's happening in the cluster. So how do you track the inventory of where the microservice is and what application version then that represents?
Yeah, so what we do from the Ortelius standpoint, we associate together the microservices, the specific versions of the services, and those are going to be represented by a version of the application. You can also think of another term for an application as a product. But basically, we're packaging together this list of microservices and their specific versions into a version of the application. Now, we're going to either Ortelius will deploy, or another like Spinnaker would deploy the microservices to an environment, and from the configuration management standpoint, we'll want to track which logical view of an application is deployed to which version, which environment. And underneath the environment, you're going to have your clusters, whether it's going to be one cluster or many clusters. We want to track specifically to make sure that the microservices are in the right places in the right clusters as part of that logical view. Now, when we do that, we're really giving you that capability to now, because we have that logical view, I can actually compare what's in QA1 versus QA7 and see the differences across the different QA environments, or compare QA to production, for example. We could do those different types of reports. Now, one of the interesting things with microservices, even though we have hundreds and into the thousands of versions of these, what ends up happening is 80% of your code base is going to become pretty, I want to say stale, but fixed. It's not going to have a lot of change to it, where we're going to have 15 to 20% that's going to be changing on a more frequent basis. We're going to have new features, we have bugs, we're going to have those type of things. We're going to do some tuning on it. Those types of high frequency microservices is what we want to really focus on tracking. And that's what's going to change from application version to application version as part of the process. So, you may think that, oh no, I have to track 600 versions of my app, my microservices. But really, when we'll get down to it, we're going to be tracking, 15 to 20% that are going to be changing. Now, obviously, that doesn't mean that these ones that some of these base ones are never going to have changes. They will, but they're just not going to be as frequent as we see with feature-driven design processes.
So what it sounds like you're talking about really is a true service-oriented architecture where organizations will be able to define kind of foundational microservices that do base level functions, and then teams will build on top of those base level functions, and you're saying the base level functions are going to be more stable, and then that 20% is what's going to change across the organization, whether if you're a bank, it's the mortgage system or the teller system or the fraud system. So is that how you're seeing it?
Yeah, so when you look at it from a domain-driven design architecture, domain-driven design, really, you try to categorize like services into what they call a problem set, where these services are going to solve a particular problem set. I think that's such a negative viewpoint to look at problems. I like to call them solution sets, where we're going to take a set of services and we're going to group them together into a domain, so we know where we can find them. So we want to, for example, single sign-on or login may be the domain that we're going to categorize maybe 5 or 6 microservices that have to deal with a single sign-on process. And then we may have another domain that has to deal with payment processing. So when we go and look, when developers go look for something, they understand these high-level domain categorizations so they can search to see if something already exists. Otherwise, they're going to go off and write it again. And that's one of the other trends that we've seen is people are rewriting the same microservices over and over and over, and because they can't find the existing ones. So we're spending a lot of time, wasted time on reinventing the wheel over and over. And domain-driven design is very important to prevent that from happening, provide collaboration, and enable that reuse that really should be in a service-oriented architecture.
So, generally domain-driven design is something that we kind of structure out on paper to really understand what we're building. How does Ortelius, talk to us about Ortelius and its domains and how it manages that, because I know that's a primary feature of Ortelius, as well as how those domains kind of relate to your SOA architecture. We're talking about the 80% that doesn't change.
Yeah, so what ends up happening in Ortelius is we literally take the problem set or solution set concept, and we enable each microservice to be categorized appropriately. And it's a hierarchical categorization, so it's not flat like a Git repo. You have a full hierarchy that you can structure and track these microservices. Now, one of the challenges it's more of from a cultural perspective, is you have to break down silos. You can't have a single sign-on routine that's been created by Project A, and they keep it to themselves, and Project B, who's going out to the same website that needs to use a single sign-on, doesn't know about it. They go create their own single sign-on. Now you have two competing single sign-ons. Who's going to win? So the domain-driven design lets the organization, through the hierarchy, bubble that up so both teams can then consume it. Now, Project A may be the one responsible for doing the development on it, and Project B may be just a consumer of it. So the domain-driven design in Ortelius is designed to have consumers and producers as part of that process. Now, when we're talking about the 80% microservices that don't change, we don't want to put them in an 80% category. A domain that says 80% hardly used or hardly changed category. What we want to do is break those out into their functionality so people can find them and reuse them, because that's the goal of domain-driven design, is to provide a high level of reuse of these services.
So you have when we're talking about then, you're a configuration management specialist, I would say. You've been a configuration management specialist in the build and release space. Now we're thinking about how to manage and track microservices and do that in an automated way. How does automated configuration management, where does it fit in the pipeline? What now is a release candidate? Because in the past we would say we have somebody checked something in, it's potentially a release candidate, let's pull it out, let's compile it, let's link it, we've got an application version, and that was our CI step. So how does that change the pipeline? Where does all this fit in, and how does it fit together?
Right. So what's happening on the pipeline side is the idea behind microservices is that they should be independently deployable, which means that for every microservice, we'll typically have a corresponding Git repo, and we'll have typically a corresponding pipeline to move it and deploy it, through the pipeline process. Now, when we look at that, we have hundreds of Git repos now, and we have things moving independently. What ends up happening is we need to insert tracking into the pipeline so we can automatically figure out what's moving, where it's at, which stage of the pipeline, what test cases has it gone through, those type of things. And that's where, like at Ortelius, we have plugins into the CI/CD tools to automatically do that. There's two steps that we need to track. First is the creation of our microservice. So typically, microservices are being compiled or built into Docker images. So after the Docker image has been created by your CI tool, we'll want to capture information about what was created. So we know that this microservice was created from this Git commit. This is the version that we're going to represent in Ortelius of it, so we can reference it. And then from there, we have that metadata or that service catalog information started at that point. Now, the next step that we want to capture is where has it been deployed to? Is either Ortelius doing the deployment, or we have another tool, Spinnaker or Helm, doing the deployment. We want to capture where that microservice has gone to. We need to track that, which environment it has gone to. Now, also in between there, we have to look at what is the logical view of the application. And as part of the build process, when Ortelius is hooked in, we'll go ahead and create a new version of the application. Because if you think about it, every time you move or create a new microservice or update it, you really do have a new version of your application. So we're going to see the number of versions of applications skyrocket. We're going to go from, we're doing a new application version once a week and deploying that to doing, if possibly hundreds of new application updates, new application versions a day. Now, what will end up happening is that those versions will get deployed to QA. We'll go through some testing, and QA will finally say, yeah, this is the version that we want to go with. And they'll talk to developers and the SREs and they'll say, yes, this is our release candidate that we're going to move forward with. And they basically snapshot that, and that's going to be the one that moves down the pipeline to production. Now, when we get into more automated pipelines, we'll look at the risk level of a microservice to see, last time, did it throw lots of errors when it went out to production, or is this a minimal risk? What are the impacts and the risk? And because of that, we can then start streamlining the pipeline to move more in a more automated fashion. But still, we need to track what is the logical view of the application that we're dealing with. Because when somebody calls in and says, I have a problem with your website, they're not going to say, I'm running, version 300 of this microservice that's breaking. They don't know that from an end user's perspective. All they know is they're running a logical version of the application. And that's where the whole SRE and the service catalog allow operations in the SRE role to dive into the version of the application, start doing diffs. This is working 15 minutes ago. What's changed? And that's the big question we get from the operations side is show me what's changed.
Yeah, I hear the term blast radius. What's my blast radius? If I push this microservice out, what am I going to impact? If
and that's
one of the true SOA.
Yeah, and that's one of the things when we go back to the domain-driven design. Our microservice is going to be shared by multiple applications. It's not going to only be in our world, but our change that we're making could affect 10 different applications that are running out there. So we do need to know our blast radius. Our change may not affect our application that we're making, but it may affect applications that are 2 seats over from us.
Yes, which is the reason why configuration management and tracking becomes important. So,
and one of the other things that we hear a lot, and this is one of the problems with the cluster sprawl, is it works on my cluster. Just like we used to have it with the developers versus the production team. It works on my machine world, and the more we can start consolidating and trying to put our arms around the cluster sprawl, we'll have a better chance of eliminating it works on my cluster versus your cluster scenario.
Do you think that this cluster sprawl has to do with trying to manage a blast radius, or are people trying to segment their application versions in namespaces, for example, and sort of pushing a monolithic architecture, using a monolithic concept in a microservice architecture by organizing things in namespaces? And I don't think that's the right way to go, but what are your thoughts on that?
Yeah, that's exactly what people are doing. They're treating the microservices as a monolith. So they'll take a shared microservice and they'll deploy it into multiple namespaces. And then what will end up happening is you'll end up with 2 different versions of the same microservice in 2 different namespaces. And now from the developer's standpoint, you may have fixed the bug that namespace B is referring to, and just because they didn't update their namespace, they're still running on an old version and getting the bug. Now, as a developer, you have to deal with managing 2 different versions, trying to get them to move over. So it really is causing headaches that shouldn't be there when implementing microservices. There are some security concerns that people raise, like I want to keep all the traffic in a specific namespace. But there are ways through RBAC and policies to allow safe traffic between namespaces in a Kubernetes cluster. So that's just kind of a cop-out that I'm seeing, because they don't want to invest the time into really looking at other ways to secure transactions. Now, one of the things that I was talking to a customer yesterday, what they're doing is they're definitely treating their microservices as a monolith. When they want to deploy, they go and deploy every single version of every single microservice to a cluster, even though if it hasn't changed. So they can't distinguish the 15, 20% are changing. So they just kind of throw their hands up and say, forget it, we'll just redeploy everything. Right. Which is a waste, and it's just overhead, and it's not easy to track the changes that are really occurring.
Well, Steve, thank you so much for being part of the DevOps Online Summit and sharing your thoughts in this very interesting area. Where can people find out more about you and the Ortelius project? And maybe you could give us one last kind of words of advice. If you're a Jenkins user and you're moving into microservices, what are some of the steps that you should think about?
Right. So you can find me if you go to the Ortelius.io. That is the open source page, and you can see my.
Spell Ortelius for us.
So Ortelius is spelled Ortelius. It's the project's named after Abraham Ortelius. He was the first person to make the world atlas. So go to Ortelius.io, and that's where you can find me. And some like parting words. One of the things I see around microservices that people are going to really struggle with is if you have 100 microservices and you have, like in the Jenkins world, you have 100 Jenkins files. If you want to go add a security scan or change a flag, you have to now go do 100 updates just to change that process. Templating is going to be key to dealing with microservices. So the JTE, the Jenkins templating engine, I see as a very good solution to that. There are some things coming out of the CDF around events, event-driven CICD. That one, I think the jury's still out because they're not addressing the templating issue. They're more worried about event vocabulary right now. But eventually, we'll get to templated events as part of that process. And then down the road, we'll actually get into more ML or AI-based CI processes, where you can look at past history of a microservice and determine which path is going to take this time. Is it going to go straight to production, or are we going to run it through QA for 3 days? That's some of the things that are going to be coming down the road in the next couple of years.
And if anybody wants to hear more about the Jenkins templating engine, we do have Stephen Tarana is also one of the CICD speakers, so make sure you check out his track, and he can tell you more about the Jenkins templating engine. So Stephen Taylor, thank you so much for being part of this, and we look forward to seeing what the Ortelius project has up their sleeves next.
No problem. Thank you.